Yeah, thank you. It's awesome to see so many of you here. It's a great pleasure for me to talk today about Kubernetes and serverless. My name is Niklas Heidloff, and I work for IBM as a developer advocate. And in my role as developer advocate, I often have the pleasure to play with the greatest and latest technologies. And two of those really cool technologies right now are serverless and Kubernetes. And both are computing options, both help you to build cloud-native applications, and they use different approaches. And the obvious question is, when should you use what? And the short answer is, the short answer is, it depends. It depends on your requirements and scenarios. And in this session today, I will give you the longer answer to that question. Okay, so just before I get started, here's the agenda. What I want to do is I want to compare these two technologies in the different stages of a lifecycle, development lifecycle. So code, test, run, and code, test, deploy, and run. And I'm going to compare Kubernetes with OpenWhisk. Kubernetes is the de facto container orchestration framework, and it's pretty much supported by every cloud provider. For serverless, though, that's different. There isn't really a standard. And every company or every cloud provider has its own solution. Lambda or Amazon started with Lambda, Microsoft has Azure Cloud Functions, Google has Google Cloud Functions, and so forth. The technology that I'm going to use today here is Apache OpenWhisk. It's an open source project that was initiated by IBM, and it's used within IBM Cloud Functions. However, most of the things that I'm going to cover today regarding serverless do also apply to all other serverless platforms. Okay, so just for those of you who haven't heard the term serverless yet, I want to give a quick introduction. Serverless is a really powerful mechanism. It empowers developers. It makes developers more productive. That's really the main goal, to make developers more productive by providing infrastructure and service for developers. Right, so there are still servers, but developers don't have to worry about it. And that is really powerful. That allows developers to focus really on writing code and providing value for customers, for end users. Okay, and that's really why I like serverless so much. I'm a developer, I'm not an administrator, and I remember very well just a couple of years ago how difficult it was to set up a new project, to find and convince an administrator to set up a new server or even to install a new version of an application server, and that has become now so much easier with serverless. So that's really cool. Now that core idea is the same idea or the same goal as platform as a service offerings like Cloud Foundry have. But the big difference is the pricing model, because serverless pricing is really attractive for many use cases, for many scenarios, because you only pay for the duration your code is executed. Okay, and a good example is something that you see here. Think about a local website that is usually only used during the day. In that case, you would only have to pay for the actual amount of requests, API requests, and you wouldn't have to operate and host it 24/7, and you wouldn't have to pay for idle time. So let's take a closer look here at this little diagram. Again, this is a serverless web application, and by the way, it's a very usual, typical use case for serverless these days. Many people, many developers use serverless to build APIs, okay, either for web applications or mobile apps and so forth. So in the left column, we have the browser, and the browser reads the static resources, HTML, JavaScript, and so forth, from, let's say, a cloud storage provider. The actual implementation happens here in the serverless functions. And there you can do whatever you like to do. You can access a database or other resources. In this case, Cloud and Tiers use a NoSQL database. And then usually you don't access your functions directly from the web application, but you put another component in between, this API gateway. And that helps you to really manage the traffic, for example, to define access rights and also to analyze how many developers or how many people have actually invoked these APIs. Okay, so that was a quick introduction to serverless in general. Now to OpenWhisk. Apache OpenWhisk is an open source project governed by the Apache Software Foundation. It was initiated from IBM a couple of years ago, and since then many other companies have joined that effort, which is really cool. And I think the probably most known or biggest ones are Adobe and Red Hat. As other serverless frameworks, you can also choose the programming languages you like to use, for example, Node, Java, PHP, what else? And Swift. Swift is important or interesting for mobile developers because as an iOS developer, you can now use your same skills to write the backend functionality for your mobile apps, which is really cool. And the reason or the thing that I like most about OpenWhisk is that it also supports Docker. In other words, you can write your functions, your serverless functions, with any Docker technology you like. And that allows you, for example, to use other programming languages that are not supported out of the box by OpenWhisk. And I'm going to show a sample of that a little later. The other nice thing about Docker is that this old developer excuse, it works on my machine, it doesn't count anymore today. Right? And one reason why that often happened was because developers worked in another environment locally than the environment that was used later in production. And with Docker, you can really minimize this risk by ensuring that you use the same environment both for development and production. And another nice thing about OpenWhisk is that you can even install it on premises, and that might be interesting for certain customers because of data security and data privacy concerns. Okay, so next is Kubernetes. Again, just a very quick introduction. Kubernetes is also an open source project. It's an open source project that was initiated by Google, and it's governed by the Cloud Native Computing Foundation. Now, Google released the first version only 3 years ago, which doesn't seem to be that long. However, Google had used it for several years before that internally, or to be more precise, the predecessor of that framework. And I think that's really the reason why so many people consider Kubernetes to be rather mature technology, including myself. And as I already said, it's pretty much offered by every major cloud provider in one way or the other, and it's the de facto container orchestration framework. Now, what does it mean? Well, when the containers in Docker started to come around a couple of years ago, the first applications that were built based on Docker or with Docker were rather simple. Often they had only a few containers, sometimes only one, where Docker was really used as a lightweight replacement for VMs. Now, that obviously has changed because many developers have started to build cloud-native, sophisticated applications similarly to Netflix and Spotify. And many more Docker containers or microservices are typically used in these cloud-native applications these days. And while the microservices themselves are rather simple and stateless, the question is, which component manages these microservices? How can the microservices interact? How can one microservice invoke another one? How can you detect bottlenecks? How can you detect circular loops and all of these things? Okay, and that's exactly where container orchestration frameworks come in, like Kubernetes. Okay, yet another open source project is Istio that I want to mention here. Istio is, or was initiated by IBM Research together with Google. It's also governed by the Cloud Native Computing Foundation, and it's a great extension to Kubernetes. It's the first thing that I always install into my Kubernetes clusters when I create new ones. And the reason why I do that is because I think it's essential for an orchestration framework. Istio is a platform to connect, manage, and secure microservices. And it gives you abilities to manage the traffic, for example, to do things like A/B testing, or dark launches of new features, or green-blue deployments, all these really important capabilities. This diagram shows the high-level architecture, and I don't want to go into too much detail about it, but I want to highlight here one key aspect, which is what you see here in the red rectangle. There is typically every pod has one container, the service here at the bottom, but there's always another component, this envoy or proxy component, which can be inserted dynamically and automatically. And this is a proxy, and all communication between the microservices goes through these proxies. And that's really Istio's way to manage traffic, and I'm going to demonstrate that a little later. Okay, so after these quick introductions, I want to now, as I said, go through the development lifecycle. I want to start with coding. Now, the good thing is that for the development of both microservices and serverless functions, you can use pretty much every programming language you want. You can use the tools that you are familiar with, and you can use your favorite IDEs. So that hasn't changed, and that's a good thing. However, if you really want to leverage the cloud, if you want to leverage things like scalability, you should also be aware of some rather new patterns, not that new anymore, but things like 12-factor applications, right, that tell you how you can design an application to really leverage the benefits of the cloud and achieve things like scalability. Then in order to implement Kubernetes applications, obviously you need Docker. You also might want to install a lightweight Kubernetes implementation on your client, and that could be Minikube, and there are some other solutions. And in order to start with the implementation of cloud functions or serverless functions, you could go ahead and use web editors. Every major provider, serverless function provider, supports or provides these editors, web editors, that allow you to just go to a website, register, say, create a new function, and you choose the programming language you want, you write your code, and you say submit or save, and your code is live. So it's really easy to get started. That's a good thing about web IDEs. Now, it's good for learning serverless technologies. It's good for demo purposes. It's not really how I would implement or how I would develop myself as a developer, right? Because I prefer to do as much development as possible locally. That includes debugging. Okay, and that's exactly what I want to show you in the first demo now. Okay, so what I want to show you is how to implement a very simple function. Okay, and I have here my currently favorite IDE, which is Visual Studio Code. And I can open up a file here. And by the way, as you see, I'm using Node.js. I'm using Node.js because, first of all, I like it, but also because it's very common to be used in serverless environments. I think it fits rather nicely into the whole architecture because of its event-driven nature. And it's also rather lightweight compared to some other languages where, for example, you might have to start a JVM first. So Node.js is typically used or often used in serverless functions. And the implementation here is really easy. There's only one main function. Some JSON is passed in this params parameter, and some other JSON is returned. Okay, so very easy, very straightforward. In this case, it's just a user profile with the first name, last name, and ID. Now, what you can do is you can embed or require here other Node modules, NPM modules, the ones that come as part of the Node runtime on OpenWhisk. If you want to do more than that, you need to create a zip file. And here's another example. Where is it? This is another function, and in this case, I require another module, string to stream, which does not come with OpenWhisk, with the Node.js runtime on OpenWhisk. And in order to do that, to use that, you can go ahead and use a package.json to define the dependency. You can run the npm install to download the dependency so that it will show up here in the Node modules directory, and then you zip up all of your code and the dependencies and push it into the cloud. So very easy and straightforward. So that's just some hello world kind of samples, how to get started. Now the more interesting question is how can you actually run and debug these things locally? Because again, at least I personally prefer doing that because remote debugging to servers is often very painful and very slow. So what I can do here is simply set a debug point, okay, and then I implemented a debug configuration. I can choose here to run my function.js, and when I click, it should bring up the debugger, and I have here all my tools and all the capabilities that you would expect from a debugger. You have here the variables, you can step over and continue and so forth. Okay, so very easy and not really different from any other classic development. Now I want to go one step further and make it a little bit more interesting. As I said, the nice thing about OpenWhisk is that you can use Docker to implement functions. And I'm using Docker now to write another function in TypeScript. I really like TypeScript. I used it a lot in a previous web application, Angular web application. And you can use that here with Docker in OpenWhisk as well. So let's take a look. So I have here this TypeScript folder, and there is a function.ts, not JS, but TS file in there. And essentially all you need to do if you want to use Docker is you need to build or provide one single endpoint, this endpoint run, right here. Okay, and it really doesn't matter how you do that. In this case, I use Express, a popular Node framework, but you could also use anything else, and as I said, in any other programming language as well. At the bottom here, I open up this port, and the implementation of the run endpoint is pretty trivial. All I do here is to read the input from the body, and I return another JSON. Basically, I just echo the incoming payload. Very easy and straightforward. And since I want to use Docker, I obviously also need a Docker file. Let's zip. Here's the Docker file. It's also very simple. I extend a Docker image from Docker Hub, Node 8 Slim. Then I copy my files. And by the way, those are the transpiled files, the JavaScript files. I copy those as well as my dependencies or my package.json file onto the image. Then I run the npm install to download the dependencies. And then I expose the port and run the application. So really, really easy. And again, the big benefit here is that this would be the exact same environment that is also later run in the cloud, okay, after you have deployed it. So now let me start this to show you that it actually works. I go here to TypeScript function, and I click it, and that launches, and you can see that here at the bottom, and that launches here my Docker container, okay, and it attaches a remote debugger. So when I go to a terminal, and let me make this a little bit bigger here, so clear, and now I simply do a curl request, a post to my local host, on port 8080, and I invoke the run endpoint. And that works, right? So it's not really exciting here, but you get the feedback or the echo response, and that's good. But now to make it more exciting, let's see how we can debug this thing. Now when I set a debug point here, okay, and I invoke this endpoint again, you can see that the debugger again shows up here, and I can do the exact same things as previously. Step over, continue, and so forth, and it works. Now, I think this is pretty cool. It doesn't really look that exciting, maybe, but it's really cool because in this case, I did not run my code in the local node runtime, but instead, this code that I just showed you in the debugger runs right now in my Docker container, and I can debug it directly from Visual Studio Code. And to go one step further, as a developer, I want to be very productive, right? I want to be able to do changes to my code and test them immediately after that. And you can do that. You can say, let's say, echo 2, and when I invoke the same container yet another time, okay, and that didn't work for some reason. Let me try it again. I don't know why it didn't work, but now it works. And I'm back in my editor, in my IDE, with my change in it. So my change was immediately deployed. And you can see that here at the bottom, because as soon as I changed something, when I click Command S, another node module saw that code was changed and restarted the node runtime within my container. And that's really awesome because as a developer, you don't have to build a new Docker image. You don't have to run another Docker container. You simply work in your IDE as if all this code would work locally, and you still get the benefits of using Docker. So I think that's pretty cool. Okay, good. So going back to the presentation, before I talk about the next stage in the development lifecycle, I want to cover one more thing related to development, which is the question, how do you orchestrate functions? I mean, I talked a little bit about container orchestrations for microservices on Kubernetes. The question is, how do you do something similar for OpenWhisk or for serverless in general, right? And sometimes I hear people saying that serverless is always so much easier than Kubernetes. I think that's true in many cases, but not always. Of course, if you compare building one serverless function with a rather complicated Kubernetes application with multiple containers, the function is easier, there's no question. But as soon as you start building more and more sophisticated, not only single functions, but serverless applications, you need to solve the same issues that you would have with classic microservices, okay? Unfortunately, as I said, there is no standard for serverless, and because of that, there is no standard for serverless orchestration either. And every cloud provider has come up or is coming up with solutions in this space. For example, Amazon, they have something called AWS step functions. Okay, and Composer is basically that counterpart for OpenWhisk. It's a really cool tool, and I don't have too much time right now to talk about it, but if you want to come to the booth, I can give you some more demos. I can show you, for example, how you can build polyglot serverless applications with TypeScript, JavaScript, Java, and Kotlin. And Composer is really the tool to glue all of these different pieces together. Really powerful. It's basically the state management component that you need to manage the state between the functions that are stateless. Okay, so next is testing. Now, testing is obviously a really, really wide area, and there are many different types of tests: unit tests, integration tests, system tests, and so forth and so forth. I'm not going to cover those types of tests today. I want to cover, however, one important type of testing, the A/B testing, which is important if you want to understand the differences between Kubernetes and serverless. Now, A/B testing is the ability to deploy a new feature to certain users, to a subset of users, so that they can test these features and so that you get feedback from these users, whether or not this new feature is better than a previous version. And only if so, you then deploy it to all the users. Okay, so that makes a lot of sense, and I think it's a critical capability for many types of scenarios and applications, for example, for web applications. Okay, the good thing is that Kubernetes and Istio allow you to do that very easily. As I said earlier, with Istio you can do this type of traffic management, and I want to give you another quick demonstration. I brought here another sample. This is a sample that comes as part of Istio, so it's not something that I created. Oh, by the way, the first sample that I showed is something that I created, and you can go to my GitHub. This is also available as open source, but again, I haven't created it myself. It's a simple book info application, and again, I don't want to go in too much detail here, so you can pretty much ignore the whole left side. The important part is here in the red rectangle. There are multiple different services, and there are 3 versions of the review service, 1 to 3, and only version 2 and 3 invoke the rating service. Okay, so that's the only important piece of information here. So let's take a look how this can be done, or how I can define and control which review service I want to invoke. This is the user interface of this web application. It's not really beautiful, but it doesn't really matter for the purpose of this demo. Okay, so what you see here is the information about one book. In the left column, there is some book details or information about the book. And the important part for the demo is here, the right column. It's the book reviews. In this case, there are 2 reviews, and there are no ratings, which you can see because there are no stars. Okay, and I can refresh as often as I like, and I always get that version, which is version 1, because remember, version 1 does not use the rating service. So, in order to change that now, this I can stop, and I can open the other editor. In order to change this, and in order to deploy certain things to Kubernetes in general, there are different ways you can do that, but I'm using here today YAML files. This is such a configuration YAML file, and in this YAML file, I have an object called route rule. Okay, and with this route rule, I can now define, where to route this traffic to. In this case, I say for the reviews service, always use version 1. So that is the route rule that is currently active. Now what I want to do is I want to change this. I want to use the version 2, but only for one specific user, the user with the name Jason, which is here identified by a regular expression. Okay, so this is the rule that I want to apply now. Now, how can I do this? I can go here to my terminal, clear, and then I say Istio CTL. This is the command line interface of Istio. And then I say -F for file, AB is my directory, and then it's, which is this, JSON? Yeah, okay. Oh, and I forgot to say create. Okay, so now I get the response, okay, the route rule was created or deployed. And when I go back to the web application, and again, I do a refresh, nothing changes because I'm not logged in as that particular user. But when I sign in here as Jason, okay, then these black stars are showing up, which means that now the review service version 2 is used. And again, as soon as I log out, it falls back to version 1. Okay, and to go one step further, slightly different example here. In this case, I want to route traffic to version 1 in 50% of the cases, otherwise to version 3. So again, I can simply deploy this here. Okay, so done. And when I go back and do a refresh, there you see that these red stars are showing up now, which means that the version 3 is used. When I refresh, it goes back to version 1 because remember, 50% of the cases, it routes to these different versions. One more time. No. Okay, so it's all, there we go. Okay, good. Okay, so let's see what's next. So the reason why I focused on A/B testing when it comes to testing is because there's a big difference between Kubernetes and serverless. With Kubernetes, you can make this very easily, as I just demonstrated. With serverless, it's not really possible. At least I'm not aware of any serverless framework that does that. So maybe there is something, but I'm not aware of it. I know in OpenWhisk, at least, it doesn't exist yet. And I think it's an important capability, but it doesn't really work with serverless because there isn't really the concept of a version. You know, and I think the reason why that is because with serverless, you want to make it as easy as possible for developers to do stuff. As soon as you introduce concepts like versions, it gets more complicated, right? So I think this is an example that speaks for Kubernetes if you really need this capability. However, there are also many scenarios where you might not need it, right? So not every application needs A/B testing, but I wanted to point it out because I think it's an important difference between these different technologies. Now, two other points I wanted to mention in terms of testing for serverless. One is, when you do the price comparison between serverless and Kubernetes, keep in mind that the tests also cost some money. Okay, so that doesn't have to mean that serverless is so much more expensive than expected, but keep that in mind because, again, a good reason or something that serverless can do very well is, you know, to handle irregular workloads and variable workloads, and keep in mind that the tests cost also money if you run, because you have to run these tests in the cloud and they cause additional execution time. And the last point I wanted to mention is that sometimes I hear that people say testing is automatically easier if you use functions compared to objects or microservices. And I don't think that's true. It is true in some cases. It's true when you talk about pure functions, which are functions where you can guarantee the exact same output for a given input. However, in most cases that I've seen for serverless anyway, this is not the case. Let's say you want to implement a serverless function that invokes some other REST API. In that case, you cannot guarantee to always provide the same output. Okay, and in that case, the testing for functions or serverless in general is not easier than Kubernetes or vice versa. It's really identical. Okay, so the next stage is deployment. And there are many different ways to deploy serverless and Kubernetes applications. I don't have the time today to mention all of them. Just a couple of examples. So what I showed earlier, and again what I will show in the next demo, is the ability to use command line interfaces. Every serverless platform in Kubernetes and pretty much every runtime and component right now has a CLI. And that's a really good way for developers to change things locally and push changes easily to the cloud. But there's also many other ways. Obviously, you can use automation in CD/CI pipelines and much more. And also two other open source frameworks I wanted to mention here quickly at least, that you should be aware of are Serverless Framework and Helm. These are frameworks on top of the core serverless platforms and on top of Kubernetes, and you might want to check them out because they can really help with deployment-related issues or challenges. Serverless Framework is a toolkit for deploying and operating serverless architectures, and the nice thing is it works not only for one, but for all of these big providers. And Helm is a packaging manager for Kubernetes application, which I will cover in a little bit later. So next, I want to do another demo. This time, I want to show how to deploy a very simple Kubernetes application, which has only one container and Nginx web server. Okay, so very easy, hello world kind of sample. Let's take a look how this works. Oh, I don't need these anymore. I created another YAML file. And again, I don't have the time to go into too much detail here. There are lots of different Kubernetes artifacts that you can deploy. In this case, I kept it as simple as possible. It's only using two different artifacts here, or objects, deployment here and service. In the deployment section, you define the image name and a particular version. Okay, and in this service section, you then define a port to make it accessible by other services. So very easy, very straightforward. Now let me go back to the terminal and do a clear. Now, first of all, let's do a kube control. This is the CLI for Kubernetes. Get pods. Get pods returns now the list of all my pods that are deployed currently. That should be here our 6 or 6 different pods that are used in the previous example with the book information application. And now in order to deploy it, I simply say cube control, and then it's called apply, and then -F for file, and then it's in my directory nginx, and the file is called deployment YAML. So I can do this, and when I now do a get pods again, this new pod shows up right here, right? So really easy to do. And to go one step further, I want to go back how easy it is to scale Kubernetes applications, or in this case, containers. So there are different things you can scale, the containers or pods. You can even scale worker nodes. I want to keep it simple here. I just want to scale the number of replicas of my nginx pod. So I change 1 to 4, go back, run the same command again with the changed file, and do again a get pods. And this time, there's actually 4 replicas of that pod showing up in this list. So really easy, it's really powerful capability of Kubernetes, but it's also really powerful capability of serverless. In fact, for serverless, it might be even easier, since serverless supports inherent autoscalability, which means that as a developer, you don't really have to do anything. It just works out of the box. It comes as part of the platform, which makes it so easy to use. Okay, good. Now, in the interest of time, I don't want to give you another live demo, but I want to at least mention the power and the power of Helm. So Helm is the packaging manager of Kubernetes, and you can use Helm to install certain pre-packaged applications or Helm charts very easily. In the easiest case, with just one command. And what you see here is a list of curated Helm charts, which you can find in the Kubernetes GitHub organization. It's, as I said, curated, and there's many things in there: Jenkins, GitLab, Grafana, databases like Postgres, Mongo, MySQL, and so forth and so forth. And it's a great way to start using Kubernetes and play around with it. In this case, I've installed Jenkins, and all I had to do was to enter this single command, Helm install, and then the name of my Helm chart. And then all these different Kubernetes artifacts are generated, persistent volume claim, service, and so forth and so forth. And at the bottom, I even get some documentation how to get started, how to find out the password of my admin, how to find out the URL of my Jenkins installation, and so forth. So really easy and powerful. And that works, in this case, it worked using default values. But obviously, you can also override these default values, for example, another admin password via property files. Okay, so the last part is run. How do you operate? And I don't have that much time left, but at least I want to mention some of these operational aspects. Now, in my experience, the monitoring capabilities that are available for Kubernetes are more mature than for serverless. And maybe that's just my experience, but I think it would make sense because there is this huge Kubernetes community. There's lots of open source tools, lots of third-party or commercial tools, and there is one big community. For serverless, it's a little bit different because, again, there is no standard, and there are many and big communities, but they are rather distinct. Maybe that's one reason, maybe not, I don't know. But there's a lot of stuff going on in the space of monitoring for serverless. For example, only recently, OpenWhisk added support for Grafana. And the tool that I mentioned earlier, this Composer tool, the orchestration framework for serverless, also gives you a really great view of all the things that happened, which function invoked another one, how long did the execution time take, and so forth and so forth. So there's many things going on in that space. Now, just one last comment here. When it comes to administrations of serverless environments, I mean, obviously, usually, and when you run the serverless or when you use serverless platforms in the cloud, you shouldn't have to have an administrator, but there can be some exceptions. And one exception is when you install a serverless platform on premises, right? As I said, you can install OpenWhisk on premises if you have requirements for data security, privacy, etc. In that case, obviously, someone needs to operate the environment, which is why you need an administrator. So in that sense, in that case, serverless is not automatically administratorless. And another example are Docker security vulnerabilities. Like, obviously there are tools, and maybe you have some developers who understand that very well. But in many cases, you might want to have an expert, someone who really understands these security issues, maybe better than an average developer. So again, maybe there are some things that developers or that other people than developers, other roles still have to do, even if you use serverless. Okay, so how much time do I have left? 10 minutes. So let me give you at least a quick demonstration of a Kubernetes monitoring tool. And there are, as I said, many, many different tools. Just quickly to give you an idea, what you see here is the IBM Cloud, and we also support Kubernetes. And from here, you can easily create new Kubernetes clusters simply by clicking a button, create cluster. You choose, certain metadata like, how big, how much memory, etc. you want. And I've done this already. And from here, I can run or launch my Kubernetes dashboard directly. Let's see whether it works or whether it timed out. Okay, so it looks good. And there's a whole bunch of information in here, way too much to cover today. But there are things like CPU usage, memory usage, how many pods are running, how many have failed. And this is here the list of the 10 pods that I showed earlier using the command line interface. And one important thing that I wanted to mention here is the concept of namespace. So now I just chose the namespace default, but there's actually more pods installed on my Kubernetes cluster. When I switch here to Istio system, you can see that there is, not found, not good. What's going on? Error. Okay, one more time. Let me open it up again. Maybe my credentials timed out. Let me refresh this one first. I think my credentials timed out, so one more time. Okay, Istio system. Yeah, so now you can see this is another list of pods, right? And these are all the pods that Istio needs and that I also installed some additional monitoring tools. And the interesting thing here is you install all of these additional tools within your cluster, right? So it's not something that you installed somewhere else, but you run them directly with your applications in your cluster. And when I go back here to default, I wanted to show quickly what else you can see here and what is important for me as a developer. Let's say I click here on this reviews service. There's a lot of additional meta information. And for me as a developer, also obviously very important here are the logs. And in this case, this should be a Java service. Yeah, it's a Java microservice, and it runs on the WebC application server. Okay, good. So I think those were the most important pieces I wanted to cover. Let me now wrap up the session. So these are some more screenshots of other monitoring tools. And all the demos that I did today are also available on YouTube, including the ones that I need to skip now because of timing. But let me wrap up the session. So if there's only one thing you should remember from the session is this slide. Because on this slide, I summarize the top 3 reasons when you should use serverless and the top 3 reasons when you should Kubernetes. So let's start with serverless. As I said, serverless is really good for variable and irregular workloads because it can lead to lower costs. And that's the example of a local website that I talked about earlier, right? And I think that's a really powerful feature. The other reason why you want to use serverless is because at least I find it easier to be used. That's not always the case. As I said, if you build really sophisticated applications with lots and lots of functions, they are not really easier than Kubernetes counterparts. But I think there are many scenarios where serverless is much easier and where you don't have to have such a huge number of functions. Which is why I say here developer productivity is really an advantage for serverless. Just to give you an example, if you want to get started with Kubernetes, right? Very often you have to use YAML files, you have to understand Docker, you might have to expose a port 3 times so that it's finally accessible to the outside, to the public, and that's certainly much easier with OpenWhisk, right? At least for the first time experience, as I said earlier, you can go to a web IDE, you say, I want to create a function, and type in some code, and it's live, it's out there. So really powerful. Now, the third reason why you might want to use serverless is the inherent auto-scalability feature. Really powerful. You get scalability out of the box. You don't have to implement anything. You don't even have to think about it. Really powerful. On the flip side, when should you use Kubernetes? Now, Kubernetes, I think, at least that's my point of view, is at this point a more mature technology, especially when it comes to deployments of rather sophisticated applications. And I talked about A/B testing, which is a good example, and I personally also think that it's better in terms of monitoring. And I think monitoring is really key. Obviously, even if you use serverless, in the best case, you don't have to monitor everything works. But we are all developers and we know that's not the case. So, monitoring capabilities are really important. But that having said, more and more is coming in that space for serverless. It's going to be exciting to see how things evolve over the next weeks and months. Then the problem or the challenge number one of every serverless platform is how to handle what they call the cold start challenge or the cold start scenario. And that means the first time a serverless provider needs to run a function, it needs to load that code and it needs to bring it up in memory and so forth. And maybe if it's a Java function, it needs to start a JVM. And that can take some time. If you need to start a JVM, and depending on your own code, it can actually take several seconds. Okay, and serverless platforms try to do everything to minimize this and to avoid this, right? They do a lot of caching and do a lot of preloading of serverless functions, etc. But by default, they can't keep everything in memory, right? So if you need to guarantee always a really minimal latency or a minimal response latency, then you really need to use Kubernetes or other platforms that are up 24/7 and not a serverless platform. I would say if you need response times from less than 50 milliseconds, you can't use serverless because you can't rely on this fast response time every time. And last but not least, there are other restrictions for serverless platforms. Usually, there are restrictions around memory and the duration. For example, most serverless platforms allow you to have functions that only take less than 10 minutes to execute. And there are also memory restrictions, 512 megabyte or 1 gigabyte of RAM. And for many functions, that's good enough, that's cool. But there are many scenarios where it doesn't work. A good example is deep learning. If you want to train your own model using neural networks, it often takes much longer than 10 minutes, and you might even have to get access to resources like GPUs. And in that case, again, you can't really use serverless, at least not at this point. So those are the top 3 reasons when to use serverless, when to use Kubernetes. I think this year and the next months will be really exciting to see how these 2 different technologies come together. And I see a lot of activities in the space of serverless where they try to make platforms more mature. I see also many activities in the Kubernetes space to make Kubernetes easier to use. So to me, it looks like these 2 different technologies come closer together. And what is really cool is another GitHub project that you can check out on, I think it's the OpenWhisk organization. It is a project that allows you to install OpenWhisk on Kubernetes using Helm with just 1 command. I think that's really, really awesome. It's not production ready yet, but it's something we are working on, and it shows again how these platforms can come together. So my last slide, here are a couple of resources. I don't want to go through all of them. Everything that I've demonstrated so far is available as open source. You can go to my blog, and here are some other resources for Kubernetes and OpenWhisk. And the last thing here, the last link is kind of interesting. We provide promo codes at the booth, at the IBM booth, so that you can use IBM Cloud 1 year for free without having to need and provide a credit card, which is pretty cool. And you can use Kubernetes, you can use OpenWhisk, and many other services that we provide. For example, our Watson cognitive services, lots of databases, and much more. That's everything I wanted to cover today. I hope you liked the session. I would love to talk with you. I would like to get your feedback. So please come and stop by the IBM booth on the first floor. Thanks a lot.
Fantastic. Thank you very, very much, Niklas. It was really, really amazing. I really loved it.